Okay. So what I'll do, so you can check your answers off as well. Is there anyone that would like to tell me what the equation of this line is? Line 2, L2. So the x-axis intercept is at positive 3. Okay, the gradient is rise over run. So the run is. So Marley was asking a question. Now it's a good question, and it's worth saying that as long as you know where some points are, you don't go in the middle. It doesn't matter which points you use to do rise over run. I can do these ones. Look, the run is 2, the rise is 1, and that's the same up here. Look, the run is 2, the rise is 1. If I went from here all the way to here, look, the run is 4 and the rise is that not the same thing? So the gradient is either rise over run is 1 over 2, or it's 2 over 4, but 2 over 4 is the same thing as a half, right? So it doesn't matter which points you can use any. So the equation of this line is then y equals this one, 1/2 x plus 3. Okay? So again, the comment is, well, is this a negative if the gradient is negative? It's got nothing. This number has nothing to do with the gradient. It's where it crosses, right? The y-axis. And we're going to look a bit more into that next lesson. So the equation of a parallel line, hopefully you would just write y equals 1/2 x, because a parallel line is the same gradient, and then you have a different number, plus 2, if you like. Plus 2, plus 1, plus 0, minus 7. It doesn't matter. Plus anything you like. Alright? So hopefully you drew a parallel line. I could just draw one very quickly like that, look. I'm being careful that I'm going through a few points, but parallel line. Right. This one that I've just drawn would be y equals 1/2 x plus 4. So, equation of a perpendicular line, well, because I'm able to, I can draw a perpendicular line without having to tilt my paper around, and I'm going to do it like this, right? So I'm going to say, here's my perpendicular line. How did I do that? Well, that's perpendicular, and the equation of this line is y equals, well, the gradient is negative, and it's a run of 1. The run is always positive. The rise is negative 2. So rise over run is actually negative 2 over 1. And then I would do x, it crosses here, so it's plus 1. Okay. Say again? It's still 4. Down there. That's 4, that's 4. Right? Plus 1. Now what we're going to be looking at, guys, is we already know that the gradient for parallel is the same. Right, that's easy, but we're then looking at, do we notice anything here? Right. So we'll go through it in a sec, but let's do this one quickly. So the equation of this line, I'm not going to do the intercept axis, I'm just going to go straight to the equation so you can check. This one is, well, the run is 1, the rise is 4, so it's y equals 4x minus 2, yeah? A parallel line would be y equals 4x plus or minus anything you like, any number you want, all right? If I were to draw one, I'm not going to, but you got the idea, yeah? So as long as you've got 4x, you've got a parallel line. The perpendicular line, again, I would be able to draw that. Well, actually, yeah, let's do tougher this one actually. So we go through here, a perpendicular line is going to be something like that. Okay, so I can see it's perpendicular. All right. So my perpendicular line is going to be y equals, and you'll notice that the run is now 4 and the rise is -1. So it's -1 over 4x, or mine is plus a half, but it doesn't matter where you plus. The important thing is the gradients, yeah? Did you all get that right? Ticking yours off. The next one, what's the equation of this line then? So I'm going to go, here's a point, the run is 1, the rise is 2, so it's y equals 2x minus 1. A parallel line to Leah would be y equals 2x plus or minus anything you like. So whatever you've got there, doesn't matter. Could be a decimal if you like. Still. The perpendicular line, right? I would draw one like this. Here's a perpendicular line. Right. What do you know about the equation of that line? It's going to be y equals -1 over 2x plus or minus, in this case 1, yeah. This one would be +1, but you could have anything. The plus or minus bit doesn't matter. Right, but in this case it would be +1, but you could have plus or minus anything else depending on where you do your line, yeah? Alright. Next one, the gradient of this line is 1 and down 2, so the equation is y equals -2 over 1 if you like, x plus 4, good. The equation of a parallel line would be, Niall? -2
plus.
Don't forget the x, and then plus,
Anything?
give me one then.
2.
Plus 2, okay? So that one that he's just said would be this line here. Yeah. Parallel line, gradient 2 goes through 2. Alright? The equation of the perpendicular line. Alistair, do you know what the equation of a perpendicular line would be yet? Anyone want to give it a go? Y equals 1 over 2, yeah? X plus anything you like. So that would be a line that looks something like this. So the one that I drew would be 1 over 2x plus 1. Yeah. What about this one? So yeah, so the run is 3, this is -1, so it'd be -1 over 3x plus 1. A parallel line would be y equals -1 over 3x minus 1, should we say?
Yeah.
That'd be alright, wouldn't it? So it goes to -1 and it has to do kind of that thing, doesn't it? Right. A perpendicular line, okay, would look something like this. Something like that. So the equation would be y equals 3 over 1 x, and I've drawn it at +2. Alright? No, you don't, do you? We can just have it as y equals 3x. Now, that leads us to what we were talking about. Can anyone just tell me what the gradients of the lines were? We've just been through. What's L2? What's the gradient? 1 over 2, L3? 4. 4 over 1, if you like. 2 over 1. 2 over 1 again. 1 over. There should be a negative in that. Some people haven't given me negative.
It's number 1.
Which one?
For number 5. Number 5.
That's negative. Negative 2 over 1.
Yeah.
Okay. So the gradients of the parallel lines, well, they're just exactly the same, right? Okay. So what we can say is gradients of a parallel line, it's going to be the same gradient. But then we look at the gradients of the perpendicular lines. If it was 1 over 2, it becomes 2 over 1, but also negative. If it was 4, it becomes negative 1 over 4. If it was 2, it's now over 2. If it was negative 2, it's now positive 1 over 2. If it was 1 over 3, it becomes
It was negative.
this was it. Which one are we wrong with? This one? That's negative 1 over 3. So then this would be just 3 over 1. Alright. So do you spot the pattern? How could you describe the pattern? Any ideas?
The numbers are swap those for the perpendicular line, and if it's a positive, it will turn into a negative.
Yep. So there's one thing. If it was positive, it's negative. If it was negative, it's positive. And what do you notice about the numbers? Yeah.
There's the flip.
They're flipped. Yeah, they swap the numerator. Now we do have a way of saying that. Okay, we should write that at the bottom. Now we didn't fill this table in. Let's not worry about it too much. All right. Because the reason why I put this in, but we haven't maybe got the time. The y-axis intercept doesn't matter, does it? Whether it's parallel or perpendicular, because that could be anywhere. We could all have had different ones. So let's just write a little note. Right, this is the important one. So parallel lines have the same gradient. Right? Simple as that. Perpendicular lines, okay, the gradient is, okay, I'm going to give you the proper words for it when my computer catches up. The gradient is what we call the negative, that makes sense, right? Because if you take a negative of a negative, you get positive. So that's how we say the sign swaps. And then how can we say it upside down, it flips? Well, there's a word for that, and it's the gradient is the negative reciprocal. Yeah. So reciprocal, we could say the numbers flip or swap. Okay? Does that make sense? So, let me just check you out then. Got a minute or two. No need to write anything down. Okay. if I said to you, here's an equation, y equals 5x minus 7. If I said to you, Talia, give me any line, the equation of any line that is parallel, you would tell me y equals parallel. Any equation you like of a parallel line. Read your notes at the bottom. Oh. What's parallel to 5x minus 7? Milo?
5x.
5x.
-4.
Negative 4. Yeah. Sam, give me another one.
Y equals 5x plus 10.
Sienna, give me another one.
Y equals 5x plus 2.
Niall, give me another one.
Y equals 5x plus 5.
Marley, can you give me another one?
7x
Anything you want.
7.
7 again. That's the same one, wasn't it?
-7.
No, I had -7. So yeah, plus 7 would work. Right, just to finish off, I know the balance is gone, but we've still got a couple of minutes. Perpendicular then. So if I said y equals 5x, but now I want a perpendicular line, that means it's crossed at 90 degrees, give me the equation.
Y equals -1/5x plus 2.
Milo.
Y equals -1 5x plus 4.
Anyone else? Understand?
Y equals
Good. All good? So perpendicular, parallel. Next job is when I say I want a parallel line that goes through a particular point, and you have to work it out. Shouldn't be too hard for you. Alright?